second lesson in the first part of our linear unit. It is slope. And the homework that goes with this is page 4 and 5. Now, I am going to ask you right now to get out a sheet of paper. And on the top, write, do not throw out. And I'm going to put linear unit. And I'm going to tell you guys right now, number one, you need to know everything that is on this paper for this year. But this is also stuff that you are going to carry over into Algebra 1 next year. So this would be something that you should keep. And we're going to add to it over the next 3 or 4 weeks. Today is just the very first day that we are putting some information on this. Now, we're going to start with a proportional relationship. The graph is a straight line through the order. The equation for a proportional relationship is y equals kx. How do we find k? K is y over x. And what does k stand for? It is the constant of proportionality, unit rate, or rate of change. And that is all review from 7th grade. Everything we did so far in 7th grade, the relationships were proportional. This is how we determined it. Now, we are going to talk now about linear relationships. Proportional relationship is a special type of linear. It goes through the origin. Every other type of linear relationship is just a straight line, and it could or it might not go through the origin. So, in linear relationships, one of the most important things, and the thing that we're going to talk about first, is slope. Now, slope. You are not going to understand all of these things right now, and we will build on this as the unit progresses. But you need to know that slope, we use the letter M. I'm not exactly sure why. I actually think that there might be a Greek word that deals with slope that starts with M, but a lowercase m is slope, and you will recognize that through course of algebra. Slope, words to describe slope are rise over run. Rise is up and down. Run is left and right. Now, the way you can remember this is you have to rise before you can run. You need to know rise, up and down, run, left and right. Now, what we have dealt with already, rise can also be change in y over change in x. Think about it. Doesn't the y-axis go up and down? That's our rise. Our x-axis goes left and right. That's our run. Another way to denote that is delta y over delta x. The Greek letter delta, which is this little triangle, means change in y or change in x. The other thing you need to know about slope, and right above this, formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You are going to need to know all of those things relating to slope. Let's talk about more about slope. If you have a line, I'm going to change colors here to keep things a little more organized. If you have a line that rises, and when I say rises, I mean from left to right like you're reading. So if you have a line that rises, you know that this is a positive slope. Any line that rises has a positive slope. A line that falls, so it's going down from left to right, will have a negative slope. Now, two other special types of lines, a horizontal line and a vertical. And I'm going to write horizontal, vertical. Now, if you look at a line that has a positive slope, it's going up. If I rotate that and I come so it is horizontal, what number is between the positives and the negatives? Because positives going up, negatives going down. And if I rotate my line, the slope of a horizontal line is 0. Vertical line, we say there is no slope or it is undefined. You need to know all four of these things. A positive line, a slope that goes up, a line that goes up has a positive slope. A line that goes down, a negative slope. A line that is horizontal, the slope is 0, and a line that is vertical, there is no slope, or it is undefined. All right. Now, let's get into the notes. The slope is the steepness of a straight line. It's the ratio of the rise, which is the vertical change, up and down, over the run, which is left and right. Rise over run, and we just talked about this. Now, we're breaking this down into just one little part. Find the slope of this treadmill. So, if I start here, and I end up here, you always start on the left. My slope is rise over run. Now, take a look at this line from here to here. That line is going up to the right, so we know that it's going to be positive. So if I go from this point over to this point, my rise, I'm going up 10, and my run, I'm going right 48. Rise over run. If I reduce this, I will have 5 over 24. So my slope is 5 over 24. It is positive. The line is going up. Rise over run. Here we go. We are looking for rise over run. Always start on the point that is farther left, just like you are reading. So my slope, I'm going to do rise over run. Take a look at this line. It is going up. So we know our slope is going to be positive. From this point to this point, I'm going up 1, 2. So my rise is 2. My run is 1. So my slope is 2. And it's positive because it's going up. Here we go. Find the slope. I'm going from this point to this point. My slope is rise over run. So again, it's going to be positive. Let's count up. 1, 2, 3. So my rise is 3. My run is 1, 2, 3, 4. So 3/4. Now, both of those were positive. I'm going to change this. Pretend I draw this line. That's not a very good line. All right. If I want you to find the slope of this line, I'm going to go from this point to this point. My slope of this line, rise over run. So I go from here to here. My rise, I'm going down 1, so -1. My run is 2. If you go down for rise, it is negative. So my slope is -1/2. That should make sense because look, my line is going down. Now, I always count from the left to the right. But pretend you started here and went to this line, or to this point. So if I start here, my rise is +1. My run is to the left 2, so -2. Isn't 1 over -2 the same as -1/2? It doesn't really matter how you count, but I usually start at the one on the left and count to the right. All right, let's look at this one. Remember, slope, change in y over change in x. So, if we're going in a table, what is my change in x? So negative 6 plus 4 is negative 2. Negative 2 plus 4 is 2. 2 plus 4 is 6. So my change in my x is positive 2. My change in my y, negative 2 plus 1 gives me negative 1. Negative 1 plus 1 gives me 0, or 0 plus 1. So my slope is change in y, which is positive 1, over change in 4, which is 4. So my slope is 1/4. And that's the same across the board, all three of them. So it is linear. All right, here's our slope formula. We've got 2 points, x sub 1 and y sub 1. Those subs just show me that that's the first ordered pair. And my second ordered pair is x sub 2, y sub 2. So I've got 2 ordered pairs. My slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, if we are given 2 points, this point right here is the point negative 4, 3, and this point right here is 1, 2. Let's do our slope formula. Our slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, label your points. I'm going to call this one the first point, x sub 1, y sub 1, and this one the second point. And I'm going to do this the other way also so you can see. So, if I substitute, y sub 2 is 2 minus y sub 1 is 3 over x sub 2 is 1 minus x sub 1 is negative 4. So, 2 minus 3 is negative 1. Add the opposite, negative 1/5. Now, that's using our slope formula. But what if I change this? What if I said this was x sub 1 and y sub 1, and this is x sub 2 and y sub 2? You could call this the first point and second point. Let's substitute this into the formula using this array. So this would be 3 minus 2, y sub 2 minus y sub 1, over negative 4 minus negative 1. Minus 4, negative 4 minus 1. So I will have 1 over negative 5. Aren't these two things exactly the same? It does not matter which ordered pair you choose as x sub 1 and y sub 1, and x sub 2 and y sub 2, as long as you are consistent. Now, the other thing that I'm going to say, if I gave you a graph like this, wouldn't it be easier just to do rise over run? So my slope, rise over run. So here I am. My rise, I'm going down 1, that's negative 1, and I'm going to the right, 1, 2, 3, 4. And I counted wrong. 1, 2, 3, 4, 5. I'm going negative 1/5. So my rise over run is exactly the same as my slope formula. All right. Find the slope. I'm going to call this x sub 1 and y sub 1, x sub 2, y sub 2. Let's write down our slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's substitute. I will have 3 minus 2 over 5 minus 3, minus 2. So I'll have what? 1/3. And if I do it the other way, I would also get 1/3. All right, these two examples are going to be exactly the same.